Okay, so here we have another vaguely chemistry related and at least glassware related project. So I have this used airbrush cleaner, which is essentially, from what I can tell, acetone but with some extra stuff in it. So what I'm going to try and do is a simple distillation so that I can try and basically reclaim it and reuse it. As you can see, there's a lot of coloration from the paint and whatnot in there. And there's also little bits that I filtered out partially. It's not great though. Neither is the seal on the sink apparently, because that keeps going down. But yeah, so I have my hot plate set to 160. That gives me about 60 some, 70 degrees with water in the little small thing. And I'm using a small one just because this will produce flammable vapors. You don't want a whole bunch of that stuff. And I'm testing out these lab beads. Then I have my condensation column and an ice bath to reduce the temperature, hopefully below the actual vapor point of the acetone. And then I have a pipe that's going out of an open window to take care of any extra fumes. So I'm going to get this going underway, and then we'll see how well it works. Okay, so I have the it's like Mr. Richer R tool cleaner. That's the airbrush cleaner that I have in there right now, and you can see it's actually quite a lot clearer than I thought. I had originally tried doing a using a separatory funnel because I thought the stuff in there wasn't quite as thick as it was, but the separatory funnel ended up not working, and then it actually, just because there was a little bit inside of the little stopper valve, it actually cracked and broke. So that really was a bummer. And then I ordered another one, but I ordered it at like 3 a.m., so it didn't have a 2440 fitting on it. So it's just a pure, like thin dropper section. So I would have liked to keep the 2440 fitting on there, but that unfortunately didn't work out. But yeah, so we have it in here. We're just gonna let it get up to temperature. And I'm going to try and maybe reseal the sink actually, because it is losing water a lot more than I thought. But yeah, it probably will take a while because this is at room temperature. And that'll give time for the water in here to cool off a little. So yeah, hopefully there won't be too much stuff left over. Another reason I'm using a tiny thing is because if there's like shit left over in there, then, you know, it doesn't matter because it's a small, cheap one. But yeah, I'm curious to see just sort of how much color carries across, if any. So it's only been a few minutes, and that low boiling point of only 56 degrees or so is already starting to, well, boil. So, yeah, hang on, let's do a little bit of digital zoom on the camera. So yeah, that's already starting to boil. I'm not going to bother raising the temperature up on this much since it should be pretty good. So yeah, these lab beads, definitely interested in see how well they work. I did try to use them before once, and they took a really long time to heat up. I guess they are meant more as a not as an alternative to a heating mantle, but more as a just like a hot bath to replace like sand or, you know, other mediums for like a hot bath that's going to stay running continuously. So it's sort of like a metallic basically medium instead that I think is supposed to be fairly easy to clean out if there's spills and stuff. But it's just sort of cleaner than sand. I think they use like what is it, glycerin, which is like really gets on everything. Glycerin is a real pain in the ass. So but yeah, that looks like it's going fairly nicely. There is a little bit of stuff in there just from, I'm not 100% sure what, but there'll be some leftover rubbing alcohol from cleaning it because I only used 70% or so. So it's not going to be totally clean. But, you know, it'll be good enough, I'm sure. So we're actually at the point now where I would expect to see the vapor basically cresting over the edge of the adapter and going into the condensing column. And there is a little bit of condensation going on in there. But I've actually turned the temperature up to 200 on the hot plate because the actual adapter here is still cool to the touch, and I realize that because The beads don't transfer the heat, I guess, quite as well as direct glass to burner contact. The rest of the apparatus isn't heating up nearly as fast as it would normally. So you can actually see all the condensation is happening right there at that joint. So I'm basically going to have to let this sit and continue sort of boiling off and condensing just in here until this gets above 30 degrees Celsius. I think 26 is the vapor point, or point where it evaporates. So once this is at about 30 degrees, that should take care of that. But that's going to be a little while from the feel of it. Unfortunately, I don't have any tin foil, aluminum foil. But apparently, I guess maybe that doesn't actually work very well, according to some posts or comments that I saw when I had posted and I had rigged up some aluminum foil on a distillation rig that I was running, I think just water. So yeah, maybe aluminum foil doesn't work. I know that like glass wool would obviously work better, but that's also kind of a mess to deal with. I also want to mention I do have a fire extinguisher handy, aside from having ventilation out the window and a couple open windows in here. I do have a fire extinguisher in case this breaks or something. So we're getting close. You can see the vapor front basically has moved up and is nearly at the point where it'll start just going down into the actual condenser. So I think I'm just going to hold my phone here like this as best as I can to try and fast forward to capture it, because it seems to be happening at a decent rate. If I had more than one camera that was like decent, and the other one wasn't just like a shitty webcam, then I could set up like a time lapse. So it probably won't be visible very well to you, but I can see it actually fluctuating up and down. I can see the line fluctuating up and down a little bit as I'm talking. Well, and looks like we have our first drop that's heading down to the condenser. Still condensing up in this section, not the actual condenser itself, but that should hopefully actually move over at some point. But honestly, I might not need the water. I guess I'll find out. Oh, actually, if we have a look, there are some drops in the middle of the condenser that are headed downwards. So I'm curious if the vapor front's actually going to go much higher than that. Probably will, and then speed up the actual distillation rate. Yeah, it is pretty cool though. I'm going to see if you can see it. You can actually see it wavering up and down a little bit right there. Oh yeah, there you go. There's a little bit of it. It's kind of zen to watch. But I'm getting tired of holding this, and it doesn't look like it's going up much at a time. This is something that I would need to set up a tripod for, so I will not continue holding this. Okay, so definitely a little slow going, but we've actually got some distillate coming over on the other side now. And yes, it is in fact starting to drip into there. Oh, and I just missed some of it going. Very occasionally it will start dripping into there. I turned the temperature up to 220 on the hot plate just in hopes of heating up the rest of the apparatus a little faster, just because it is slow. Let's see if we can capture another... Hey, there we go. Alright, so yeah, it's distilling across. It looks crystal clear right now, but of course it's in still fairly low concentration on that side, and this side's fairly high concentration, so we'll see if there's stuff from the leftover paint. The red color is from enamel, but there's going to be residue of acrylics and some lacquers in there as well, so we'll see if any of that stuff carries over. So interestingly, the actual distillation has slowed down to the point where there's no condensation up in this section anymore, and the temperature hasn't dropped or anything really. I mean, on the hot plate. So that is curious. I guess that tool cleaner R stuff is not entirely acetone, because there's a fair bit of it that came over, but it looks like that's actually stopped. So maybe now there's something else in here that is sort of like a higher condensation point. Yeah, everything is nice and warmed up, so that's interesting. But yeah, you can see the boiling rate has come down considerably, so I'm not sure if I want to just add some more in and let the easy stuff come across, or if I want to increase the temperature and try to get this to come across too. I don't know. We'll see. So I figured for good measure I'd pop a thermometer in there, and it's just long enough to actually reach the liquid. And it looks like it's nearly at 115 degrees Celsius in there. So yeah, I wonder if maybe that stuff is diluted with water partially. I'm not really sure what that stuff is. Yeah, unfortunately, I can't really find like an MSDS or anything, and it's also all in like Chinese or something, or Japanese, the tool cleaner stuff. So I don't know what it's actually made out of. But there is something that definitely has a much higher boiling point. So I'm gonna add in some more and let that pop over, and then see how that affects it. Obviously, I'm getting some sort of solvent that has a low boiling point over. That is maybe just acetone, but then there's some sort of extra stuff in here. Maybe that's in part because it's combined with like the paint and whatnot, all the extra shit in there. But that's still like half of what I put in, so that's interesting. So I've added a bunch more in, and the temperature of the actual liquid did drop to 60 degrees just because of the stuff being at room temperature versus the hotter stuff inside. But you can see instantly the boiling is taken off as vigorously, actually more than it did before. So I've moved the thermometer up to where the actual vapor will be coming into the condenser, and we'll see what that ends up being at. So right now it's at about 43. But yeah, it's interesting. I don't know what that stuff is made out of. I can't imagine it would be 50% water. And even if it was 50% water, it was 110 degrees in there, but it has extra stuff in it. So I wonder if maybe it is diluted with water. Although it is some toxically, like, horrible smelling stuff. So yeah, I don't know. I mean, I'm getting, or I got clear distillate that came over at, a similar boiling behavior to this one. I didn't bother checking the temperature then. But you can see we already actually have our temperature coming up around just under 60, and the vapor is actually right at that point. So that's characteristically evaporating and boiling off basically as acetone would at 58 degrees or so. It's close enough, margin of error, that I'm pretty confident that it would be acetone that's coming over based on the smell and how the stuff is designed to strip paint and clean paint out of an airbrush. But I don't know what the other 50% of this stuff is. I do have some left, so I can actually measure out. I don't have a graduated cylinder, but I can measure out by weight, not by volume, how much is coming across in another run. So see how much of it is what is presumably acetone, and see how much is this leftover stuff. This ended up being more interesting than I was expecting, honestly. And a little disappointing that there's so much extra stuff left over. I was hoping I would just have a rag that I wipe the inside of the thing out with, some paper towel, and that would clean that. But yeah, it looks like we're just going to be pulling off some more acetone, and then there's going to be a good 50 milliliters at least of whatever that other shit is left. So that's probably going to be the end of this video, but I might investigate more into this at some point. But yeah, this is gonna take quite a while now, so I'll leave it running. But yeah, that's the distillation apparatus for recovering airbrush cleaner, which seems to be 50% acetone and 50% who knows what, maybe water.